Okay, welcome again to the Connected Car event, or the IoT automobile is what I call the CanCam project. Who is here tonight that wasn't at the prior month's meeting? Who's new tonight? So more than half of the audience. I'm going to repeat part of my presentation from last time and go through it a little bit faster, hopefully. We had a great initial meeting last month and squeezed about 3 hours worth of content and discussion and networking out of that event. I own 7 electric cars. I have 4 Toyota RAV4s with a Tesla drivetrain, motor, and battery. I have a Think, which was a startup in Indianapolis, Indiana, and some antiques, a commuter car and a commuter van. If you remember the autonomous cabbie that drove Arnold Schwarzenegger around in Total Recall, I have one of those. Why do I have so many cars? I can only 7 electric cars. I can only drive 2 at once. I'm working on a project called V2G, or EV2G, Vehicle to Grid. The 42 kilowatt hour battery pack in my Toyota Tesla has enough energy to drive the car for 135 miles, but I only have a daily range of about 40 miles. So there's 85 miles of unutilized energy in the battery pack just sitting there in the driveway. That's enough energy to power my house for a week. So that's one of the projects that we're working on with electric cars. It seems like the electric car, certainly the Tesla Model S and X and the new coming Model 3, are becoming a platform for not only just electric drivetrains, but really the best example that the car is becoming more and more computerized. Some of these systems are open systems, as in the Tesla. You can certainly gain access to the maintenance and the GPS system. But for the most part, the computer systems out of Detroit are a closed system and we don't have access to it. This was kind of uncanny in this discussion about electric cars, which is what the other 2 speakers tonight will be talking about. This was the Dilbert from yesterday and today. Let's start an electric car company. Well, let's start a company around electric cars. I'm going to move back one slide. Well, I move forward. This is our first door pilots question. Is this the canonization of Mother Teresa, now Saint Teresa, this week in the Vatican, or a Trump or Clinton rally, or something else? Anyone know?
Butane ordained.
Yeah. This is Woodstock 47 years ago. So we have no winner on that question.
Trick question.
Trick question. I like this little cartoon. I've shown this 3 times now, but it's still valid. I stole this off the IoT of Amsterdam, Netherlands website. It's on their header, the IoT lab. Same cartoon, same little guy here. In the corporate world, we shouldn't do anything new. It's too dangerous. In the startup world, we shouldn't do anything old. It's too dangerous. Which I think speaks directly to the innovation culture that is emerging among all these startups and co-working spaces like Galvanize and another half-dozen co-working spaces that have emerged just in the past 2 years to feed this very robust startup community in Austin. As much as Silicon Valley or Boston, Austin is the place to be. And for a startup, I don't know why you would do anything old unless you want to be conservative and take the old path. But then you're not creating any revolution. You're just trying to capture market share away from someone else. So I think this is very true in a general sense. That is a Tesla that got wrecked. The battery pack and the motor up front have been destroyed, so this car is going to be a total loss. But for the most part, electric cars are very safe and very reliable. An electric car, just compared to a gasoline vehicle, I can sum this up in a nutshell. Electric car has no oil, no gasoline, no radiator fluid, no transmission fluid, no belts, no pumps. So all four of the fluids and the systems that move them around go away. The only thing left is the motor and the battery, which are very, very reliable. In fact, by federal law, electric cars have an 8-year unconditional warranty on the motor and battery. So you'll be out of the car by that time. I'm a strong advocate of electric cars. Now, of course, Tesla suffered a lot of flack over the fatal accident a few months back or earlier this summer, where the guy was playing his Game Boy or something and not even watching the road, and even ignoring alerts in the computer that it was having a difficulty tracking the roadway. Well, in the 350 million miles of autonomous driving in the Tesla realm, this is the first fatal accident. Statistically, in that number of driving miles, 350 million miles in a human-driven automobile, there would have been 50 fatalities. So statistically, autonomous driving is here. It's only going to get better and better. I actually prefer not to focus on autonomous driving. There's other people better than that than me.
And Dan?
Yes.
A gas car will blow up.
Well, that's another good point. You know, there were a few fires in the early Fisker, or maybe there was a puncture of the battery pack before they put a skid plate on one of the Teslas. But every year, 30,000 gasoline vehicles burn to the ground with either a gas fire or a fire in the electrical harness that burns the car to the ground. So I have some new content here. And these are all real short. We're going to go through these fast.
Things by taking advantage of technology and sensors. So our next speaker is Jeff Baer, and Jeff is a MIT alum. He got his MBA in 2006, and apparently took a class from me in 2005, but did well despite. And Jeff has this really exciting technology. It's the Internet of Trucks, trucking. The world goes, we today ate something, drank something, wore something that came in a truck. And Jeff is going to tell us about his world and what he's doing there. Jeff.
Thank you, sir. Hi, again, my name is Jeff Baer. I'm the founder of LinkDrive, and I'm going to try to do this chronologically to stay on task a little bit. I love things. I'm a mechanical engineer, and I can understand things. The internet was a little bit black art to me until I came here. And trucks move things, and trucks are things. And to me, a motor vehicle that's been built in the last 30 years is really its own little Internet of Things, because it's a network of sensors and actuators and switches and human beings. Which, you know, to get to that point, to me, the Internet of Things is interesting because of the way human beings interact with those things. And when I was an engine calibrator at Ford Motor Company around 2000, it took a lot of thousands of dollars worth of hardware and software to take a little bit of data off of that vehicle network back to Dearborn, to the supercomputer, to fit regressions and think, how do we calibrate air, fuel, spark with all of these networks of sensors and switches. And you know, if you added $8,500 onto the price of an F-150, it probably wouldn't be the best-selling truck in the world. And I, after MIT, was at a barbecue with a classmate, and he showed me how he had connected his late model Beamer, because he was a consultant or a banker and not an entrepreneur. He's streaming data to his iPhone, and there I was with my BlackBerry. And he Amazon one-clicked me a little Bluetooth adapter and said, all this can be yours if you get an iPhone. So at that time, I was also running commercial vehicle sales at A123 Systems, selling very highly valuable, designed at MIT, made in America batteries, and worked on a project with FedEx and with Navistar. And when I realized the batteries were in question, which ended up they were fine, we had to ship via FedEx at our cost 10, $55,000 batteries from the West Coast back to Michigan just to get the data off of them. I thought that's not very efficient. And the combination of that and the experience I had in Somerville, just barbecue with the iPhone, I thought, wow, all of this data that used to be so hard to get is now actually very easy to get. And there's probably a lot of value to be had. So immediately I went to fuel economy, right? I was selling, 4 or 5 figure batteries, to trucking companies and OEMs on a 3 or 4 year payback and 5 to 7 year life cycle. And it was almost like asking the customer to pay for all the fuel they were going to save on day one with that model. And the financing models weren't really that effective at that point. And I thought, basically, the program in Navistar, the trucks had to be able to go 100 miles. And a lot of the drivers couldn't go 100 miles on what the specs said they would need from an energy perspective. And we had to FedEx the batteries from California to Michigan to figure that out. Put it all together, and I thought, well, 30% of whatever your MPG is has nothing to do with the driver or the battery or the system. It's only the driver's right foot. Daimler, Cummins, the ATL agreed. And now I can get that data and do something with it. I don't need to go back to Ford and become an engine calibrator again. We can do this aftermarket. And that's where the idea for Link Drive and Pedal Coach was born. But as I said in the beginning, to me, it's mostly interesting because the trucking industry certainly doesn't really want a lot more data. Some people might say they will, and some of the big companies know a lot about data, but they need applications that change human behavior. And we've been compared or called, the Fitbit for fuel economy for truck drivers, and that's just where we're getting started. To me, a human being is an actuator. And, the data comes from a sensor. And now all that flows very, very easily, right? So the world is definitely our oyster. This trucking industry is woefully behind in so many ways. And it's a little bit of an orphan industry compared to the consumer market that's driven down the cost of everything else. But the value propositions are so high. It is a game of inches, and time and latency are very important. So the liberation of that data back to the central locations is cool, but what's way cooler to me is to actually put in front of the driver a feedback loop to help them do the best they can with what they have to work with and run that calculus locally there. To me, to me, that's what the Internet of Things is. It's not about more sensors and more data. It's about changing human behavior with the solutions that are built on that. So ask me anything. I'd be happy to talk trucks. And it's really, really energized to be back at MIT because there are a lot of actuators here.
Thanks very much, Jeff. Our last speaker is Frank Gillette, and Frank got 2 masks.
Sorry. Okay. I got just bored enough with that. I'm only going to play one more. This one's very corporate. I apologize.
Welcome to Intel IoT Discovery for the automotive industry. The intelligent, connected car makes driving safer. With a half second of warning, for example, over 60% of collisions can be avoided. With a full second, over 90% of collisions could be avoided. Exterior-facing sensors and technology can provide these warnings. Intel is partnering with a broad community of auto manufacturers to help develop in-vehicle innovation. We're jointly creating solutions where systems and devices embedded in the car can communicate, providing data to help reduce congestion in a smarter city and monitoring their own performance to manage and schedule preventative maintenance. Intelligent systems respond to driver and passenger profiles, monitor and adjust fuel efficiency and driving performance, and calculate best routes by accessing real-time information about delays. Consumers can also maintain their connected digital lifestyle. They can receive secure over-the-air software updates for their vehicles' onboard systems. Our high-performance, scalable, cost-effective technologies provide world-class security for data shared between the car, the cloud, and other systems. Discover how technology can keep you safe and more connected now. Visit intel.com/automotive.
I really apologize. That was not the one I wanted to run. This one actually has some buzzwords in it I learned something new from. This is it.
We know how critical data security is with our internet-connected phones and laptops. But what about your car? Cars today have more computing capabilities than ever before to keep us safe and comfortable. They use dozens of interconnected embedded control units, or ECUs, for enhanced vehicle management, premium entertainment, and remote telematics. Cars are also more connected than ever, which increases their attack surface and the risk. In the future, that risk will only grow as cars connect to the cloud, traffic infrastructure, and even to each other. The vast potential of vehicle data can deliver untold driver benefits, including greater safety and convenience. But before we can unlock the value in the data, we must trust that the data's entire journey, from ECU to cloud and back again, is secure. This includes vital vehicle control systems, which must be protected. The problem is that traditional security solutions don't scale down to ECUs. Finding a solution that does is crucial. In collaboration with Germany's Technische Universität Darmstadt at the Intel Collaborative Research Institute for Secure Computing, Intel is exploring what it calls trustlets, which enable security to scale to the ultra-small devices that help manage critical vehicle systems. This research aims to dramatically advance the trustworthiness of embedded devices, enabling vehicle security to reach levels currently enjoyed in the cloud and our connected devices. The solution is distinguished by the flexible, efficient isolation of computing tasks. This allows only the most critical hardware and software in car subsystems to be protected. The breakthrough research conducted by Intel and the University of Darmstadt represents an important step forward in securing today's increasingly intelligent car. It also reflects Intel's ongoing commitment to helping its automotive partners advance automobile safety and convenience.
Okay, did you catch the two buzzwords in there?
Trustlet.
Trustlet, yes. What was the other one earlier than that? ECU, that's a common term. Increased attack surface.
Yeah.
I like that. And it's true, as cars become more computerized and more complicated, there's more things to go wrong or more things to hack. Another purpose of the MotoJuicy Can project. That's a general term. Here's the landscape of patents among 24 companies in just automotive communications patents, so everybody's in the game. Here's the logo we're going to use for our project. Waveforms coming out of a little car there. You'll see two words to dominate in this project. CAN, meaning the Controller Area Network, or EVAN, the Electronic Vehicle ID number, which is the main application that I envision. I'm going to skip some of this stuff about charger technology. The CAN Area Network is 25 years old, invented by Bosch. It is very reliable, 125 kilobits in a car, up to 500 kilobits in a factory floor arrangement, although it dominates in vehicles today. All production vehicles everywhere in the world have a CAN port or onboard diagnostic plug on them. These are some of the applications that I envision. In the middle there, I thought it was interesting, this term V2X, or vehicle to everything. We need to think of what is the car connecting to. Well, the cloud, certainly, or the internet, the road itself, garages and parking lots, the parking slot in a garage, adjacent cars, phones in the car, and what I call car to cabin, all those consumer electronic devices the kids are running in the back seat, and car to person as we have more wearable human interfaces or wearable IoT devices. The EVIN, or electronic VIN number, is the main application of the device. It will also be a CAN bridge device between two mating devices. And here's what they'll look like. The first gentleman from MIT, Internet of Trucks, talked about going to Amazon and getting a Bluetooth adapter. Well, here's said adapter that comes with a little CD with an app for both Android and iOS, where I can read the onboard diagnostics of any car and do a reset function. It doesn't do anything else. This is a similar device. This actually serves up an entire Wi-Fi web page, so you could see it with a laptop or any device. So these are the current state of the art in wireless CAN adapters out of China, about $13 to $15 each. Really a bargain for what they do. Some of the apps that we envision for the CAN adapter, the word CAN means controller area network. I'm going to put our electronics package in a metal or plastic can, rather, about twice as high as this. So it'll plug in under the dash and add Wi-Fi, Bluetooth, and then optionally GPRS or a 5G connection. So the apps are really numerous. I just thought of some more apps today of what we can do if we had access to the CAN data in an open fashion, and really all the computer systems of the car as much as possible. Most cars today have a low tire pressure sensor in the wheel of the car. And they have to be replaced from time to time. They're about $35 in discount electronics, but apparently they're all the same. All the ones I've ever seen don't discriminate between which tire it is, left, right, front, rear. It just tells you one of the tires is low and an alarm goes off on the dash, and you still have to figure it out. Apparently there are some luxury models in a Mercedes and Cadillac that will break it down per wheel. But for the most part, the low pressure sensor doesn't tell you which tire it is. It'd be useful if we had more.
My Chrysler 2013 tells me which tire has how much air pressure.
So really, it reads the pressure amount or just a low pressure alarm?
I get a digital readout of the amount in each tire.
Really? How sophisticated?
So that technology must have become more mainstream.
Really, per wheel?
Yes.
All my cars just do it for the sum of all four wheels.
It's 2007.
Okay. Well, we could have a low jack feature where the car could send its GPS location. This is probably possible already through third-party services. The electronic, the vehicle ID number is well documented. There's been discussion both ways. Is this proprietary information or open information? I would contend that the VIN number is open information. All that's contained in the VIN number is a unique identifier for the car, and if you know the codes, also the make, model, and year of the car. This is useful information. It's already printed right on the underneath the front glass of the car and on the side door panel, so it's not like anyone just walking by can't read the number. So broadcasting that number unencrypted, I think, is very useful. This whole idea started with the last two bullet items, public ESVE, that's a electronic charging station for an electric vehicle. I started this discussion. Right now, to charge with public charging stations, we need to use a credit card or from the vendor, either EVgo, Blink, or ChargePoint in this market. and set up an account and have them debit the account. And it would be nice if the charger could just identify the car, or the car could identify the charger, and they communicate wirelessly with no, the billing information already set up, and no card required. So that's where this whole idea started, a car to charger communication. These are the chipsets I decided to use. Not all of them have come in. I've ordered a half dozen of these. I've only received the one Nordic RF52832, which is pretty nice, about the size of a postage stamp, and on there is a Bluetooth 4 and BLE radio and a 25 megahertz 32-bit ARM M4 core.
You have blue backup?
Well, I considered that, and I decided to go with the Nordic part, unless you have arguments otherwise.
My only argument is I know it better, but if you said you only received one, so if you wanted to evaluate the other one, I've got one. I've got three, actually.
Oh, really? Okay. Email me, and we'll get together this weekend.
You owe me an email.
Yes. They are almost identically spec'd with the 32-bit M4 core between the Blue Gecko and the Nordic part. The reason I chose the Nordic part, it seems to be more popular in more devices out there. I don't know if that's a good proxy to
The software is the differentiator.
the development environment or the firmware on board.
I would say the development environment. The firmware is probably different too, but I don't, that's invisible to me.
You can use the Eclipse for both of them, doesn't matter.
Which one?
Eclipse, open source project, Eclipse, you can use the, I tried them both. Eclipse for.
So that's the development environment you prefer, Eclipse.
Yes.
Okay.
I like simplicity.
And you don't need any compiler, you can use any toolchain from ARM, and then you can add a toolchain in the Eclipse and you can compile the stack.
And you said you prefer.
I like simplicity better, but even Scilabs likes their new,
It doesn't work on Linux.
well, they have some environment that like more than simplicity. I forget. Like, of course, like simplicity better than embed, and I agree with on that.
The problem for simplicity doesn't work on Linux, so it has some bugs, but Eclipse is perfect for Linux.
I see. So Eclipse works in a Linux or Windows environment. Simplicity is a Windows environment only.
Yeah, simplicity is more.
On VMware software.
Yeah, but for the port, sometimes the USB port is not recognized if you're using a virtual machine or something like that. So I think that.
I see. So like the Adreno, the Linux platform is more reliable to get over this, whatever the issues are around the USB port.
Yes.
Anyway, I think I established my point. The software is a differentiating factor.
Between the two chipsets. And at the IoT device meeting we had up at Sherlock's a few weeks ago with the robot from IBM, they had a beacon using the Qualcomm part. I haven't studied that enough or know if it's identical or a big difference. You know anything about the Qualcomm Bluetooth? Silicon?
I think it doesn't matter if you're in the IoT and you have to use the open source hardware, open source software. You have to be able to use any hardware for any software. In the future, we are going towards the open source concept. So I think it doesn't matter.
I see. So remaining true to this open source and open platform, we can hop around as necessary. I'm going to skip this. That's the preferred electric car charging connector. There's 4 different types, no clear standard there. I think we'll see more of these solar-powered car charging stations. That is a one-line diagram of the CAN part, and I'm not sure what silicon came on the adapters that we ordered. We ordered a CAN to Adreno stamp or shield, just to save time there. That is a pictorial of what it's gonna look like on the header board. That is the Nordic part on the left, and then an ESP8266 on the sevens on the right. This gives us 2 radios, Bluetooth and Wi-Fi, and 2 processors, an Adreno and a ARM. I like this blended approach because it gives us all kinds of I/O in something the size of a postage stamp. And even though those are 2 different processor core architectures, they're kind of equally supported, and using just a simple piping structure between the 2 processors, one or the other can be the primary and the other the secondary, and handle all kinds of I/O. David?
Dan, I just got an email this afternoon that there is a new ESP 3212 that just come out. It's about $7, and it has Wi-Fi and Bluetooth on it.
Really?
Yeah,
Yeah, what's the power on it? What's quiescent?
I didn't look that far
That's
enough.
what I'm worried about.
Yeah.
You know, we have enough room in the CAN plug to easily squeeze those 2 parts, and you know, it's gonna add up to about $7. So until we see those, I have these in stock. James mentioned the Thunderboard. I'm open to that. I actually like the fact that the development board has 4 different sensors on it between Hall effect, vibration, temperature, and light. This is a GPRS module from Siemens that could be an option in the same package. One of the potential applications back to an EV charger is called submetering. It would be nice to be able to know how much electrical energy is going into the car, which can be substantial over time, more than just being part of the grand total for the whole house. This is called submetering. If we knew what energy the car by itself consumed, it could be separately accounted for, maybe at a different rate from our electric company. It's even been proposed that with the access of electricity at night, as we have here in Austin and most utilities in the United States, that we could charge our cars restricted at night for free and restricted from charging unless we had some override during the day. Submetering would be necessary to segregate the car's consumption from the rest of the house.
Dan, I think Austin Energy is offering submetering for electric cars for a resident.
Yes, and they want to charge you $850 for a second overkill Landis & Gyr wireless AMI meter. So you have 2 expensive watt-hour meters. It'd be possible to create a revenue grade, they call it, watt-hour meter built into the car charger to avoid that, I think, unnecessary cost. So there is a program for it. It's just not economically appealing just yet. There's a Tesla Unwrecked. I think this embodies the state of the art today, and we'll see more and more of this. It's my contact information. I have some things I wanted to give away. I haven't posed any valid questions. No one got the Woodstock. Well, without repeating the slide, what is the ARM core inside the Bluetooth parts?
M0.
Wrong.
M3.
An M4. Okay. Do you want a 16 gig USB stick, James?
Oh, yeah, I'll take one. No, I don't.
Okay. And here's a question. What is the second largest regional market for the Tesla automobile in the United States?
Storage.
Austin. Correct. Okay.
What's the first?
You probably don't need this, but another 16 gig stick. We all need thumb drives to move presentations around.
What's number 1, San Francisco?
Well, the Bay Area, yes. where the car's made. So I think that's interesting. They've sold 800 of the cars here in Austin. And there's a new service center just opened at 183 in Palm Springs. It's huge.
And there's
Sales
a
and
Tesla
services.
store at the Domain too.
I'm sorry?
There's a Tesla store at the Domain too.
Yeah, the showroom, but now they have a big showroom and service center in Palm Springs. Just finished. They'll probably have a ribbon cutting ceremony in the coming month.
How do you buy a Tesla in Austin?
Online.
You know, I can speak to this. We have the,
It's legal in Texas, isn't it?
we have the Texas Automotive Dealers Franchise Act, which is a polite term for a conspiratorial lockout.
Not exactly.
By,
The purpose of the act is to protect the consumer because a vehicle is going to be one of the two largest purchases that you make in your lifetime, your house being the other one. So the purpose of the act was to ensure that if you bought a car, you could get the car serviced.
yes, there's arguments both ways. It simply says that a automotive manufacturer must use a dealer, an intermediary, a dealer, like a GM or Ford dealer, a Maxwell Ford, a Covert GM, as an intermediary to provide that local service and support along with the sales to engage in retail sales in Texas. That's the premise. Tesla has a service center here and can service the car. Tesla's business model, the car is already pricey enough. They don't want to work in the margin to cut in a dealer. I don't know what a dealer's margin is. It might be 30 or 40% of the retail price, which would increase the price of the car and bring in a middleman, perhaps unnecessarily, if they're already providing service. The Tesla, I think, transverses a narrow path within a state law in Texas, and they've tried to restrict this in other states unsuccessfully, where they are very careful at the showroom in the Domain to not mention the sale price, the dollar amount. You have to look it up online, so they don't talk money. And when you order the car, you do it online, and you're ordering it from the head office in California, and it's shipped to you on a car carrier here. So the transaction is a interstate transaction protected by federal law, which transcends state law in this case. So you can still buy a Tesla here. It's just the numbers are not discussed. In fact, they're not even negotiable. They are uniform across the country. So it's a fixed price. There's no point to negotiate around the number.
Yeah, I mean, to this point, I just bought a Tesla, so, I mean, they titled it in California. You don't pay sales tax to Tesla. They basically FedEx you a title like you're buying a car from out of state, and you bring it to the tax office, you pay the sales tax, and then you get your plates and registered here and transferred here.
So normally a retail dealer would be holding your hand through the registration process. On a new car, you have to do that yourself.
Did your Tesla show up on a car carrier, or did they have it in the back and they just shipped you the title?
No, they showed up on a car carrier, which actually, I bought a pre-owned, so it shipped from Atlanta, and it was came with a Georgia title.
So they're hand delivering each car individually from California? That doesn't sound very efficient.
Hey,
I'm from Sweden. This is the most dysfunctional capitalistic market in the world that I've ever recognized. Seriously. I mean, cars is one thing, but telecommunications, utilities, there is no functional competition.
We're also 50 countries together.
Yeah, but I mean, I'm just comparing versus EU, where you're streamlining and working towards one regulation system. And here we talk federal, 50 states, and I've been in telecom for a long time. There are counties to some degree and city codes. And you have to deal with all these different layers. It's just messy. But I mean, I'm here, I like it, I was just making it
well, there's
something
else you should add to this conversation is that, like buying any other car, the best value is going to be to buy one used from a local owner. Dan and I just sent one over to Dan that we found here in Austin, a white Model S P85 Performance for like $52,000. mint condition with panoramic sunroof.
That's a very good price.
It was a really
It's half
good deal,
price.
and then you could get it within a day. And same thing, you go to the tax office and get your registration there.
There's also
And
car
that's your best value if you really want the best practical way to buy one.
I saw that Tesla's opening a brick and mortar store right by my house, Andersonville 183. You can see the big old symbol right there. I'm talking about.
Yeah, it's in Palm Springs, Palm Springs.
It's open.
It's open?
Yeah. My car was delivered there and serviced there.
So this may be an ongoing battle. Apparently, it hasn't affected the ability of anyone to get the car. I don't know if it's inefficient to deliver the car in a car carrier straight to the customer. That sounds like a just-in-time, minimal inventory approach. If you can still touch and drive and see the car, an identical car at the showroom at the Domain.
When I picked up my 2014, which was $50,000 off the list price that was sold in 2014, it has autopilot and all the sensors and everything in it. There were 25 new ones coming off a truck that day, and I asked, are those spoken for? I said, every one of them was spoken for. Minimum price, $90,000. So clearly they're doing okay out of business.
Yes.
I had a question about the CAN network. When is that, I thought it was actually going to be transitioned to an IP network. Yeah, right now it's using a very old protocol.
It's 25 years old. There's this new LIN network for automobiles, which is a one-wire versus a five-wire system,
So,
which is IP based.
so given, you know, how old the CAN protocol is, I mean, what's the forum's view in terms of really what we can do with a CAN network these days?
I think the internal networks, as Lynn is doing, will be changing what's going on behind the door panels and underneath the hood of the car.
Yeah.
But in terms of consumer access, I think that the OBD port, whether it's CAN or not, is going to be there for a long time to come for emissions testing, and this is a natural place for the consumer to plug in an adapter like the Wi-Fi Bluetooth bridge CAN adapter that we're proposing to interface to the car.
So you're thinking that in order to interface into a rather archaic network, in order to get it on IP, you would have like that Bluetooth or Wi-Fi interface.
There may be some other bridge, exactly.
Or some type of telematics RF module like what OnStar has, or you know, what a lot of other manufacturers have put on their cars for 4G network connectivity.
Well, someone in our last meeting that worked on the BMW production line contends that most cars have a Wi-Fi network built in for testing within the factory floor environment that is then disabled when it comes off the line.
They do. I mean, the cars are enabled with macro and micro cellular, you know, networks, radio access networks. But again, they're just accessing the PIDs, you know, like you would if you were over your ODB2 connector. So they're not. I mean, they're doing the same thing we're doing. They're going back to, you know, the archaic approach to getting to reading sensors and ECUs and all this other stuff.
You know, for me, the best thing that the CAN port or the OBD port provides is a constant 12-volt DC supply, unswitched ahead of the ignition switch. So I got full-time 12 volts available. I can blow off everything else.
Yeah, speaking of that, in your PowerPoint slide, when you put the solar power charging, did you ever consider presenting and Xing out the inverter?
Oh,
You don't need an inverter. A buck inverter is a heck of a lot simpler circuitry than an inverter.
so your suggestion is to what you say?
Solar power, all you gotta do is buck convert that down to a DC 12 charge for your lithium ion, and you eliminate all the inefficiency of your inverter.
Yeah, but I don't think you can presume that you always have light available in a parking garage
Unless
or.
the batteries are inverted. I mean,
And we had talked about this last time. This is one of the functions, besides the electronic VIN number, it's a battery health monitor. If we're powered by the 12-volt battery, we can know what the battery voltage is and set off an alarm if we're running the battery down. This actually happens to the Tesla and Toyotas. If you don't drive it once every 1 to 2 weeks, the 12-volt system battery, which maintains the battery management system for the larger 600-volt traction battery, will run down, and you've got to then use a 12-volt trickle charger to jumpstart the car again. So it's a little anticlimactic in that regard. To the Nissan Leaf's credit, it has a solar panel on the back of the car that provides a trickle charge to the 12-volt system battery. And I used to have 2 Nissan Leafs. It never ran down. It worked.
I think we can use some protocols like ZigBee or 6LoWPAN to add the sensors on the battery and talking and track the kind of bidirectional communication from the battery to the cloud. So we can real-time monitoring the things inside of the car with these protocols, because this protocol doesn't need any bridge or any converter. So we don't need, I think the new protocol is coming in low power wireless. It's going to replace this protocol because it's less expensive, low power, and more secure. And all of this IP based. We can establish the VPN IPsec from the sensor to the cloud. So I'm just.
So you're suggesting a LoRa network or what's that?
6LoWPAN or IP, ZigBee IP, this kind of low power LP-WAN actually. I think it's going to dominate this area in the future, and it's going to be less expensive. I know BMW is working on those protocols to add the ZigBee to inside the car, but the IP, ZigBee IP. So we are going to assign the IPv6 to the pins, and we can real-time monitor the cloud. So we can find out any problem.
What's the range on that?
For LoRa, we can go
No,
for
ZigBee.
ZigBee IP depends on what kind of physical layer you're using. It's between, this is Wi-SUN actually, and it's used for the AMI, Advanced Meter Infrastructure. This is a 6LoWPAN, and it's between 10 miles, and in the very dense environments, we can maybe 1 mile. Very dense environment.
That mesh or?
Yeah, full mesh network.
It's mesh, okay.
Yes.
So this is a good note to close on, so we can move on to the next presentation. But apparently, to cover all the bases, a car today has 6 radios in it: the Bluetooth, the Wi-Fi, the LoRa network, the
Sigfox.
the ZigBee network,
And Sigfox is coming also. Sigfox is another one.
competitive networks in terms of low power, low data with long distance. Then you have the GPRS module that I showed for positioning. And then whatever the cell phone flavor of the week is, 5G, 6G, is presumed for the long distance communications into the cloud or the cellular network. So this is a minimum of 6 radios. Apparently cars are very connected and becoming more so, and it's a bucket of wireless modulation systems.
Yeah, our challenge is the integration of all of those programs.
Yeah, it's not-
Because everyone's talking the different language.
Yeah, they're not connected, even from the manufacturer,
Yeah.
they're not connected.
Well, in the CAN device, we're going to do the minimum of a Bluetooth to Wi-Fi bridge there. I think that's presumed. I'd like to introduce Michael Walsh with Evo World. Michael, thank you very much.
Thank you. How about our for Dan? Wow, thank you so much. I'm really glad to be able to have a chance to present to such a nice crowd, very intelligent crowd as well. So I really welcome your feedback if you'd like to talk afterwards. I'm not an engineer. I've self-taught myself through just personal study, mainly the bigger picture of smart grid and the interconnectivity of how the electric car can become such a great part of what I call a trifecta, especially for a homeowner with solar on the roof, battery storage in the garage, and an electric car, which disconnects you from the fossil fuel economy, and could even disconnect you from the grid completely and be a grid defector, which I think is very cool too, especially in places like Hawaii. So Dan has helped quite a bit with this project, and we just have three relatively small investors right now, but we do have three great investors in the pipeline that we can present to shortly, and including People Fund next week, which is over here in East Austin, part of the Sustainable Center they built, which includes a Sustainable Food Center. And so the People Fund could be a great prospect for us because they're very interested in social impact projects like this one. So we do want to be a transportation network company and go into directly in competition in the rideshare market here in Austin using 100% EVs running on the Green Choice program of Austin Energy, which is by quota 100% renewable energy. We may not be able to do that in other markets, but we do have a city-owned utility here, which is a luxury that we should enjoy. It generates about $100 million every year that goes back into the city budget from Austin Energy, so that's a nice amount of money that goes towards a lot of public services. So what we can do with Evo World, which is completely out of the league of the other rideshare services, so we can be much more connected with the city and local employers as a natural ally in sustainability to reduce emissions and address congestion here in Austin. So Austin has made a big declaration that they want to be net zero by 2050. It's a great goal to have. Transportation is obviously a big part of the emissions here in the city. And in a second or third phase, if the company is successful, we would like to move into the creation and build out of electric charging infrastructure, also known as EVSE, support equipment, EV support equipment. And we'll look at some of those later on. So this is a really game-changing car right here. The Chevrolet Bolt is in production now. It will be available in showrooms as early as December 16 or January 2017. It's a 200-mile range electric car, which is going to be about $35,000 before incentives. So $7,500 federal tax credit plus your state incentive. In Colorado, they're relaunching their EV incentive, which is going to be $5,000, I believe. You can get the car for $27,500, go 200 miles, travel the country at what I like to say, near zero fuel cost. And electricity is really inexpensive for electric cars. So, not that we're going to stop disasters like the big Deepwater Horizon disaster a couple years ago, but we can say that we're not part of that fossil fuel economy because we do not need that infrastructure to run our cars. Why would you want to use an electric car for rideshare? Well, it's a whole lot better car. It's much more efficient. It doesn't pollute. One of the great advantages I found while driving the RAV4 EV for Uber for 8 months was that if you're sitting around on a slow night and you're waiting for rides, well, you run the AC all you want. It just it's a slight dip in the battery, but you're not idling and polluting nonstop. I rode my bike over here so I could park for free at the YMCA. This morning I came across this really big City of Austin truck which had brought a bunch of sod down to re-sod some area by the hike and bike trail, and the engine's running. And the guy's sitting on the back like this, and the door's open on the cab, and this diesel truck's just running and running, and I tell the guy, why don't you shut it off? He goes, well, I'm waiting for the driver, so he didn't know. But, there's a lot of ways that we can reduce emissions in the city, but we have to get serious about it on many fronts, and I think rideshare is a really great place to start. Quick look at subsidies. You might hear a lot of right-wing commentators always complaining about subsidies for solar or wind. Well, this just shows you the amount of subsidies for solar. It's 1/72nd as much subsidies that are received by the fossil fuel industry. And you can see the stat there. Would be $7 over 5 years would be your portion compared to you're paying $521 towards subsidizing some of the richest corporations in the world like ExxonMobil. So how would we also change, in other ways, change the rideshare landscape? And once again, I think the electric car is the best car, of course, if you're gonna do any kind of carpool program and start scaling that up with our local employers, and I'd like to start with the major high-tech employers who are very data savvy and that might be more inclined to do such a partnership in order to identify clusters of employees and start bringing 5 employees in one Nissan Leaf, which we have here, in one electric car, and that takes 5 gas cars off the road, and then you're addressing air quality and congestion in a cool way. And then a third phase of operations would be direct EV rentals, and that's like the car-to-go model that you have here downtown. I heard recently that they're going to be phasing out these little 2-seater smart cars because they're really not, they don't have much capacity at all, and I think they're dangerous. If you get hit in one, your odds aren't very good in competing with a larger vehicle in a wreck. So we can offer the Nissan Leaf, again, as a direct rental off the street, and we found out from some friends in Sweden that they're adopting like an Airbnb model for the car. So they will host an electric vehicle at their home and keep it charged up and then put it on the street, making it available for rental for all their neighbors. So that way if they need to run errands or groceries, things like that, you can hop in a car like that, rent it by the minute or by the hour as you need, and then return it anywhere within the service area. So these are 3 phases of operations. We want to start with rideshare. We want to go in directly and compete with the approximately 8 competitors that are active in the Austin market right now. Such companies as Fair and Fasten, Wings, and the nonprofit, which was started by a couple of tech titans here in Austin, the Ride Austin, which is a nonprofit. So none of them are even talking or looking at using EVs at all. And so we think we have a great story to tell, and that's a big differentiator, and a lot of people would like this as an option. The reason I put a little scooter here, picture these little scooters have really come around in the last couple of years, and now can go like 20 miles an hour. The front forks will telescope down, it folds up, you can grab it, you can carry it with you in the bus, or we could put 3 or 4 of them in the back of the car. We could lease them or rent them out to our clients, or we could sell them with an agreement with the manufacturer of the scooter. And that makes a great way to get around. It's super easy to use, and it solves that what they talk about in transportation, especially if you use a city bus. That last mile dilemma, how do I get from the bus stop if my house is still 15 blocks away? That discourages a lot of people from using public transportation. So we can move into offering options like that, once again, things that the other competitors are not doing yet. So here's our big opportunity is used cars, especially the Nissan Leaf. Here's an example of one of cars.com that's for sale, super low miles, only $9,500 for a very well-equipped Nissan Leaf, which we can, it's a very capable car. The limitation is 85 miles of range, but we can overcome that with extra cars and frequent fast charging. You have the fast charger here in the front. You have 2 ports in the front, the 240 volt or 480 volt, 100 amp, which is the Chattanooga standard. If we do scale this up a lot, we would need a lot more fast chargers in Austin to operate successfully, and that might be accomplished with crowdfunding the creation of charging stations, which we talked about, or a partnership with Austin Energy so we can roll out a whole lot more fast chargers. And we are finding out that as electric cars become more and more mainstream in Houston, the NRG EVgo system, they have 40 to 50 fast chargers already. So you can see they're way ahead of Austin in Dallas and Houston with the NRG EVgo, which apparently installs very good equipment, does a very good installation. We're a little bit disappointed with some of the work done by ChargePoint here in Austin, but it can only improve. This is the car that Dan has 4 of, and I have 1 of. It's the RAV4 EV, which is, in our view, a tragedy that they only made 2,600 of these and then just stopped because it was a temporary contract between Toyota and Tesla to satisfy the air emission rules in California. And so it was built between 2012 and 14. It's the identical car and same chassis. It's all built off of 2012. And all the cars are identical except for the color. There were 3 different colors offered, or 4. And fantastic car for rideshare. It's got extra room for luggage, of course, it's a bigger SUV than the Leaf, and it has a longer range of 110 to 120 miles.
What's the brand new price on that?
The car retailed originally at $50,000, and here's a mint condition, 40,000 miles for $20,000. So it's like getting almost 2/3 off the original cost of the car. And like Dan said earlier, I mean, these cars are super low maintenance. Every once in a while, there's a software issue that you have to take it into the dealer to get a software issue or a little seatbelt issue. But it's like your iPhone on wheels, plug, keep it charged up, and it'll go and go and go. Here's a great deal. We're talking about Teslas on the used market. Here's one, 28,000 miles, under $50,000. I believe this was just a 60 battery, but nevertheless, with the 60 battery, you still have 200 miles of range. So it's a very capable car, fully loaded panoramic sunroof. I believe it had a lot of other options too. So this is a car that we could use as a third choice in our offerings. So primarily Nissan Leaf, RAV4 EV, which would do, in best case scenario, we'd only be able to get about 50 of those because there's not that many of them left on the market. But the Teslas are available in abundance, and we can offer that as a high-priced rideshare or move into specific rentals for weddings or corporate events or just a executive car service with Wi-Fi on board, of course, and other amenities.
Do you know what's the driving force that people are spending $100,000+ for these brand new cars?
When the used market is available?
Within 2 or 3 years, they're selling them for like 48,000.
Well, to Tesla's benefit, I mean, out of a list of 50 cars, the Tesla is the one that's holding its value the best. The Nissan Leaf was ranked 49th out of 50 in holding its value. The only one that was worse was the Mitsubishi i-MiEV. Is that how you say it? i-MiEV? And the Mitsubishi i-MiEV was a terrible car. It's got a pretty substandard interior, and it's not an attractive car, so that's probably why it deserves the 50th ranking. But to speak to Tesla Model S, why would you buy a brand new retail car? Well, any brand new retail car, you drive it off the lot, you're losing, value immediately. So it's an expensive proposition to buy a retail brand new car, always.
But it's also very risky to buy a used car in Texas where it's floods all the time, other issues that wouldn't necessarily get reflected in the car. They should.
Good point. So this is just a scenario like I don't know how many we would end up getting because we would like to go into for our rideshare service, move into the newer cars like the Chevy Bolt as soon as they become available through a fleet purchase agreement and a loan package agreement, possibly with a local credit union or a commercial bank that wants to put up money to acquire these cars. And we'll develop a program to put our drivers directly into the brand new Chevy Bolt, for example. But in the meantime, this is how we can start the company and start rideshare right away. So these existing used cars, 2013 or newer, the first year was 2011 for the Nissan Leaf, but the car got significant improvements starting in 2013. So we could brand them and modify. This Nissan Leaf actually has a Fender FX package, which makes it look a lot sportier and a little cooler. So we would need the more fast chargers definitely as we move forward. And so phase 2 would be getting the newer EVs in a fleet purchase. So quick back to the napkin calculation. If we did have 1,000 drivers, an approximate revenue model would be about $480 per month per car. So if we had 1,000 cars, so other benefits that you got to look at with the pure electrics compared to Uber and all the other competitors is that Uber throws, and others, they throw all the expenses are pretty much thrown onto the driver. That's depreciation of the car, purchasing the fuel, maintenance, and so on is all on the driver, and the driver has to absorb those costs. In our business model, if we're leasing or getting our drivers to buy with our assistance, possibly a new car, they're going to be much, much better off because of the lower operating costs and lower maintenance. And if they're leasing from us, they will not be experiencing any depreciation. We're going to look to provide direct phone support and cover the maintenance on these cars. We want to engage the community and make as many strategic alliances as possible. And we would like to offer with our partners a monthly networking party, which would be great, where we can give a brief presentation to onboard new drivers, which is critical. We're always going to be looking to hire more drivers. So within our partnerships, we would encourage corporate partners to do solar installations such as this with electric car chargers underneath. Even if you don't use it for electric cars, you can park other cars and they would be in the shade. And if you do a significant installation like this one, then you're looking at, you can start powering your building and all of your cars are in the shade. And based on the way that looks to me, I mean, that could even be rainwater collection as well for your landscaping. So you see a lot of benefits. Some people call parking lots the Saudi Arabia of energy, because you can really look at generating quite a bit of energy on site, which is a very sustainable proposition. The closer the power is to where you need to use it, the better. We're looking at communicating with HEB about possibly doing a demonstration EV charging station, so maybe 10 parking spots with a solar canopy and charging stations underneath. And if we're successful in building out that kind of energy infrastructure, that's the fueling station of the future for your electric car. Really high visibility. We can have corporate sponsors can brand these stations as well if they pay for part of its construction. Once it's built and paid for, the energy can be free. And a lot of us in the EV community believe the best way to drive EVs forward is to make the energy free. And a lot of people love that. It's a very direct realization of how cool the electric car can be. What if your gas car, all of a sudden, you could get free gas every day? That's never going to happen, but this can happen with the electric car. So I said maximize sponsorships for each station. Crowdfunding could even become a part from a local community standpoint to raise money and then figure out the 5-6 different ways you can fund the creation of a station. Here's one here on the left, on top. And some other examples. I really like the ones that have an artistic or a nice design aspect to them, like this curved one. It adds a nice, rather than being completely flat, adds a nice flavor, and could even add landscaping or vines. So other differentiators for our model from Uber and Lyft. I added this because I just found out I added this to the slide today. Uber dropped their requirements. They used to be a maximum of 10 years old. So if you order Uber or other competitors, the car could be up to 15 years old. Whereas, so we're looking to brand ourselves as more of a premium rideshare company with newer cars, more connected cars, and definitely technology on board to match that. And we can do things as we move forward, not everything right away, of course, but do some sort of sustainability membership, do a sustainability pop quiz, gamify the experience, so to speak, so you can make it engaging and fun, and give the riders another incentive to choose Evo, other competitors, maybe some sort of point earning system where you can give away prizes or perks or free rides and so on to just gamify the experience and all around the concept of sustainability. And here's how you would maybe go up levels 1 through 5 in that system in order to get to more sustainable options in your lifestyle day to day. And here's potential partners. Silicon Hills is right here in Austin. We've got tremendous, incredible market that I think is hugely untapped. We have got to get serious about carpool programs, whether they're vans, shuttles, or dedicated city buses, park and ride systems to address traffic for us. How else are we going to do it? It needs to start soon, or Austin will become Houston or Dallas the worst. So this is the realm of that Dan was talking about, is all the connected car capabilities. 1,000 Nissan Leafs would represent 2.4 megawatts of power, then you become an interesting this is kind of pie in the sky for us and a dream at the end of the rainbow, but it's definitely cool stuff to think about in the future.
You just said that wrong. 1,000 Nissan Leafs would be 25 megawatts of power.
Thank you.
Not to
A lot more, right?
Yeah. 10 times.
And so then, of course, you'd want to use that if you'd obviously have to have the two-way connectivity of the car giving back to the grid, and you have to have all that technology in the homes or at the charging stations in order to give back at the appropriate time to achieve peak shaving. So when the demand is really high in the grid, you could actually use the cars as your backup battery to give to the grid to reduce the overall demand that's being asked for on the grid. So vehicle to home is great in case of a blackout. Like I'm saying, you can power your own home, vehicle to grid as well. So we had a really great presentation at Clean TX about a year and a half ago of this project they have just south of Austin, close to San Antonio, where they're doing a big research project, which is V2G. And they're using things like the big commercial delivery vans, 100% electric, like Frito-Lay delivery vans, and so they're exploring that V2G technology.
There's your math error right there. Top line would be 24 megawatts.
Thank you.
Alex.
I will fix that. So conclusions. We can say that we're definitely addressing climate change. We're zero emission on renewable energy. We can take cars off the road, especially gas cars. Be a premium rideshare service. The cars are available at super low cost. So if you were to choose gas cars, I mean, the electric cars are already much cheaper than a comparable model. So why would you not use the electric cars that are available? I see them as stranded assets, and it's a tragedy if we don't put these cars to work. A lot of them are sitting on Nissan dealership lots, and they're not selling because of the lower range. So here's our team that we have in place right now. Dan is definitely helping us. We should add this picture soon. And we're looking to present to 3 or 4 investors in the coming weeks. And I'll leave you with this quote here, and welcome all of your questions. Thank you.
My name's Grayson Schlichting, and I've been working with Dan on this, and I want to talk just a little bit about a development platform, not what we ultimately envision the can being in terms of form factor, but while we're trying to figure out what functionality we want to do, what kind of flexibility we want to have, we want to see what we start to put together very quickly. So we want to be able to provide a development platform to various aspects and features of it, and make it a simple, quick start while keeping in mind eventual migration to, like I said, Dan's desired footprint and cost goals and everything. Down arrow. So right now, what we're initially doing for reading the ODB2 port and looking at the data, and what will be interesting out of the data is entirely, of course, out of form factor. It's using a seed can shield right here, which is an Arduino shield, Arduino shield that goes on here, and that gives you a quick way into the bus, and there's lots of libraries available for it, and of course then the Arduino, and then this connects with the DB9 cable to the ODB2 cable that's underneath. They also make, you can do pass-through, like we were talking, or like they were talking to, they also make things for this kind of purpose. There's a little twofer that lets you duplicate the port, not two ways, so you can reuse the port. Here's one that's I like better based on a ribbon cable. So that's kind of how we'll be doing it at the time. I've got one of these, like you showed, a Bluetooth dongle that was $14-15, plugs into here. And as a matter of fact, I pulled a Wireshark on it today because, of all things, my check engine light came on. So I was like, woohoo! But what I had to do for that, I'm waiting on one part. The one delay in the part is this guy. He's not going to show up until tomorrow. So I haven't been able to go on the with it, but what I did was I've got a Bluetooth sniffer, and with my Bluetooth sniffer, and what's this here somewhere? I usually kind of show and tell. My company is Toy Box Technology, so do always things with the toy box little stuff. So I use my Bluetooth sniffer and try to sniff the conversation between this and the torque program that you can get for Android, iPhone, all of that, to find out what's going on. It's kind of interesting because it puts it into our chart, but that was that was a mess of a protocol path. That was completely, reverse engineering from the ground up, having to look at everything from the packet level. But I did manage to actually find the fault codes coming through and all of that, but, trying to decipher all of that. Yeah. So this will serve as a good platform since, like I said, the libraries are there for the different standardized types of things that you can receive off of the CAN bus and monitor off of the CAN bus. I was going to put a slide up for that, but I didn't have time to prepare that slide. But it's typical stuff you would expect to be able to see. And then we'll have to do some experimentation. So, this is a rather large type of setup to do that. But again, what I wanted to do was get us quickly into developing and playing with the technology. And then we know how everything can all shrink and fit and scale down. I don't know why that got put in twice.
Do you know what the silicon part is on the shield, the seed can shield?
It is the, somebody with glasses. I've got it written down. What are they using? They're using the HPC 2515 on this shield here. And what you can do is basically we can take this form factor down completely, since Arduino is not the target platform. Something that may be able to be programmed in the Arduino environment like the 8266 is, but all of this can be reduced down to this right here. This is a $5 part, which has got, comes in two flavors. It comes in SPI or RS-232, but here is the two main CAN signals that come off, which is CAN positive, CAN negative. You put those in or plug them in however you want here, and then pull it off serially. So basically there's, a path to getting out of this to shrink that down, and in terms of cost and size, I mean you can judge by the size of how big these are as to how tiny this thing is. It's just a little tiny board, much smaller than it shows up there.
So, question, I'm curious, what's the objective? Are you just trying to pull PIDs off of the CAN?
Trying to pull any sort of data that it's willing to give us. What we want to actually collect, I'm not sure yet, so I'm making a platform that will allow us to collect whatever we want. If we wanted to just get the PIDs off, I mean, there's more information than just the PIDs that you can get, but if I understand the question right, which are like error codes and things like that. I mean, there's a lot of the real-time data, the vacuum and all that kind of stuff that you can pull off as well.
Yeah, but I mean, like, Torque has already done that.
Right.
All these vendors have already done, they've already decoded. I mean, it's the PID, they're leveraging the PIDs from the ISO specification.
Right.
And there's PIDs that are manufacturer specific that
A lot of them
don't have, but the tuners, the companies that develop the tuners, they've gone and demystified or bought licenses from the manufacturers or whatever. But I think it's still based on the same technology, right? They're leveraging the PID protocol for the.
They are.
Yeah.
And so so what we want to do with the data, we're not sure yet. That's sort of what
Well, being an open platform, we want access to everything, at least in terms of reading what's happening on the Carport, and where applicable, to write to the Carport.
But even like with Torque, you can define your own PID, even using the Torque application. I don't know if you tried that before.
Yeah, that's what I've got.
Okay.
That's what I did the Warshark capture off of, was the Torque application talking to my Bluetooth dongle and my Jeep.
Yeah, and you actually gave an instruction, a PID instruction specifically, because Torque allows you to, if you've got like a manufacturer specific PID that you want to do a read on, it'll allow you to send that PID if you know what the PID ID is and then what the parameter input coming back should be. It'll allow you to do that.
Yeah, I didn't mess around much with that and haven't. I don't think there's a lot of that kind of information flowing around my vehicle. I've got an 03 Jeep Wrangler Rubicon, so there's only engine information going around. I don't have all the other types of interesting info that's flowing around the port.
You talking about like what we were talking about, like the tire inflation information, all that stuff?
That's just one example.
That's all gonna be like manufacturer specific information.
And none of this is published, that's part of the problem.
Exactly, it's all proprietary to the manufacturer.
Right.
It doesn't mean it's not available at the port. It's not encrypted either.
Correct.
And so that's why I wanted to start with this setup here, because there are a lot of libraries out there right now, Arduino libraries that talk to this board that are manufacturer specific. So we can use this as the development platform to learn about and see what types of PIDs and types of data we'll want to be able to read, possibly write. Like I said, when I'm running my Jeep on Torque, it's actually kind of uninteresting because, I mean, nothing except for my engine and emission controls is in there. It doesn't know if I've got my lights on or my blinkers are going or none of that information like that.
Apparently there's some useful data there in this unpublished realm of CAN data. I think of that, I don't know what they call the thing, Flow from Progressive Insurance. They push this little Carport adapter, and it's apparently illegal in some states, but legal in Texas, where they will snapshot your driving habits for a month, and then give you a specific rate for how heavy you are on the accelerator, or how quickly you brake before a stop sign. I think are useful information on the level of risk you pose as a insured client.
I always feared having one of those in my car.
Yeah, we test those modules, but they've already got their accelerometers and everything inside the ODB2, so they're not actually pulling that data off the car. They're pulling like acceleration data, immediate braking data and stuff like that, but they have accelerometers and GPS, all their stuff on that.
I see, so really it's just getting the 12 volts from the Carport.
That, and it's binding it to the vehicle.
Yeah, I mean, you do get information like, you do get the accelerator, you can tell whether someone got the accelerator forward.
Yes.
For instance, that's data that comes out. So just real quickly, in terms of, again, the development platform and put together, Wi-Fi connectivity, hate it, love it, I don't care. We're going to go with the ESP family, ESP 266, because it's quick, it's easy, it's actually got a very powerful processor built into it with capability left over, even though it's doing the Wi-Fi part of it. It's a 32-bit pin-cylinder, the Harvard architecture device that runs normally at 80 megahertz. You can double clock it at 160 megahertz if you don't care about power. And we're on 12 volts coming off of the vehicle. I don't think we care about power, not in the same fashion that we do if we were running off of a LiPo or a point cell, something like that. So kind of programming ports right here. This one happens to be familiar fruit. This is the actual module itself. These are the ones that are $2 or $3 that you can get off the internet. But programming them, reprogramming them is no easy task. So if we're going to be loading code onto these and using them as a development system, we want to kind of in this format at a minimum. We program these up, and then what I've also got, I've brought an example, pass around both of those. These are the breakout boards. You can't hurt that thing.
Really break out now.
And then just to make it faster for programming and prototyping and everything else, using this breakout board here, which is over here. So I don't have to worry about 3 volts because this has got the 3.3 volts regulator on it. Can do 5-volt conversion. It lets me program it using a USB port instead of an TDI cable. And it also happens to support a LiPo battery and charge it. So these are the 2 base kind of processors in ESP8266s that we'll be looking at. We'll have to look at the one that has the Bluetooth integrated. Most interestingly, in terms of how much of this guy is left over, it's a very high performance processor. So I don't know what adding Bluetooth is going to do to that, or if they maybe upgrade the Tensilica core on that Carport 3212. And then Bluetooth Smart. I actually had not seen Dan's slides, but I think we're sort of in agreement there. Starting off with, I'd like to start with the Nordic 51822, just because it's a mature product with lots of tools and libraries, and pass this around. But here's one that this one operates off of. He has a 3-volt battery holder. Lanes into the beacon and Eddystone beacon, but that and this are the same, except that one's RS-232, this one's 5. So you can see the size, postage stamp kind of size of what these guys are. And again, there's rich libraries for these guys right here. But when you get down to it, this is the silicon labs board. Ready to go?
I was just wondering how much you had left.
Okay.
We could officially break now. If anybody wants to stick around, stick around.
I got one more slide. That's fine. And then this is the BGW111, the Thunderboard React board. Actually, they've kind of under-flattering themselves. It's got more on it than what they show here. It's also got 9 degrees of freedom accelerometer on it and everything. So this would be something to possibly go to in terms of Bluetooth chips, very low power. It does have a nice IDE. Believe it or not, you program these things in BASIC. BASIC, beginner's all appropriate, simple all construction. You know, that's fun. So, but the board itself has actually got a lot of other sensors on it. It could be interesting as sort of a black box board. Here's what the Thunderboard looks like. Pass that around, and we only got a few more slides. The cloud peer connections utilize one ESP8266 as the client, and you've seen in one of the presentations what it'll do is it'll look around for charging stations and other like-minded devices that would start an SSID of like MotoJuicy or some sort of number after it all. And then we would either connect to the one with the strongest RSSI, or we can modify the membrane scheme to detect quality service or type of device that we want to connect to. So that's how we can connect Wi-Fi to the outside world. In vehicle Wi-Fi connections, we utilize the USB 8266 as an access point. So that's for, that's not about all the kids in the back seat playing with their toys, playing with this, playing with that, and all of that. Also another gateway into diagnostics, UI, entertainment system, movie storage, and all of that. And then whenever you're in range of a Moto XXXX or another citywide network like Time Warner Cable, stepped on the cable. Time Warner Cable's all over downtown, basically. So you'd be able to pick that up through MAC as a bridge there, and then this would also manage the BOE network as a bridge. So the Bluetooth network would be managed through that as well. So you kind of be speaking bilingually. And then for outside cloud connectivity, utilize an MQTT-like service when connectivity is available to upload and pick up any missed screens. I'm not using Mosquito. Somebody could talk me into it because it does not deal well with devices that are off the air. It's more like the FedEx guy. He will come and bring it to you. He's bringing you something every day, and he brings you the next one. He'll pick up the one that was still left. So it's not ideal for connecting on and off. So currently, what we're going to do is publish a redundancy to IM.Adafruit and also a FANT server on AWS. I've got that already up and running for this DC too. And then what we can do is store data. We decide we want to collect onto an NFC card, for example, and then batch all that in when we get connectivity, retrieve any lost messages, because unlike Mosquito, these two services here, the data could be like a regular CSV files, XML, JSON, or anything like that. And then constant connectivity options, which you pretty much cover. You got, and these are old technologies, but here's a GPRS data and voice module. Here it is in the same form factor as the Feather, the other device that I'm passing around somewhere. And then this is the Spark. What am I trying to think of? Well, I'm having a weak brain. The Proton. This
Particle photon?
Yeah, this is the Wi-Fi or the cellular version of that, which it's got the core Cortex M3 on it. It's got a SIM card so you can do the data storage on it, and then it's got the data going in and out. So there's options, and the prices keep dropping. Form factors keep dropping all the time as to what we can do to provide constant connectivity. Right now, for constant connectivity in my vehicle, I use a Carmen Go. I turn this on, and it's a Wi-Fi hotspot for up to 5 devices in my car or wherever I'm at. It utilizes the T-Mobile data network. But
I saw cell phones have a hotspot on it.
But yeah, you can turn your cell phone into a hotspot. Yeah. It's kind of the same sort of thing. You buy data on this particular guy, you buy 10 gig chunks and they never expire. So he's just a little carry around Wi-Fi hotspot. But anyway, so we do have wide area networking options through cellular to get off there, and that is it. That's the last slide. So I was just showing you some of the pieces and parts that we'll be pulling together so that we can begin to play with some of this stuff and take a look at it. I mean, some other interesting things, gas, CO2, sensors and things like that. That's what this is. This little guy right here. So maybe throw one of those in to know we're getting carbon monoxide or something. I don't know if all the modern cars have that. I know my 14-year-old Jeep sure doesn't. And that is it. where we were talking about starting from and then heading to, we've got a path to get things small, light, and expensive, but we'll start off with bigger devices, bigger things like that, because there's so much code base out here, for especially this combo right here, manufacturer specific kind of